Hello, good morning. I still remain Ubong Edim. Before now, we have to descriptively talk about what computer is made up of. We have been able to see why computer is different from other electronics, and we have been able to talk about the definition to define computer in a different way. Not quite different, we added something that made it distinct. Where we say that computer is programmable. Okay, so today we are going to talk about the fundamental units of computer. Notwithstanding, we know that computer is divided into two parts. So we are still going into that, but today we are just looking at the fundamental units. Apart from the fact that we know that computer has classification of parts divided into two, which is the software and the hardware. And I believe we are still going to look into that. Today, we look at fundamental units of computer. We have division of labor. If you go to school, you go to market, you go to any establishment, you see that there is division of labor. So that in like way we have units of computer. So they are divided into 5. The first unit is input unit. Input unit is a unit through which data and control signals are given to unit through which data, and from our definition we said that computer is an IPO device. I stands for input, P process, while O is output. So the unit through which you can input, you can give command to the computer. The unit through which you can interact, because computer will not act except you command it. You say do this, do that. If you don't, and even when you say do this, do that, it must be in a proper way. You give the command through a proper method. So the method, the way through which you command the computer is through the input unit. Okay, so I can say that input unit is the unit through which computer user interacts with the computer. That is to say, without the input unit, computer cannot work, because if you don't command it, it will not work on its own. So the hardwares belonging to the input unit are known as input devices. So examples of the hardware that make up input unit, which are what we call input devices. Example is the keyboard. We have the keyboard, we have the mouse, we have joystick, we have light pen, we have trackball, scanner, graphic tablet, microphone, magnetic ink, card reader, optical character reader, barcode reader. So I have been able to include some of the pictures here. So if you look at the screen, you will have the keyboard. This is the keyboard. This is the unit through which we type. You type something, all those alphanumeric keys, you get them through the keyboard. So we have the mouse, we have the scanner, we have barcode reader. For instance, your ID card, nowadays they use barcode scanner to scan your barcode. So not just somebody drawing lines. If you draw lines, there must be a database through which the barcode reader can use and authenticate the numbers or the lines that you drew. For now, you have some people, some drugs. You see, you have some drugs now having expiry date. People can go and fake that thing. So with the barcode scanner, it will be impossible. It will be second to impossible to fake it. We have light pen, we have optical card reader, we have magnetic ink reader, we have digitizer. All these things are input devices. So in digitizer, let me just pick you and explain. I have explained the keyboard, the mouse, we have the scanner. The scanner is the unit. You know that we have two types of output, two types of information. We have the soft copy, the information that you see on your monitor, and hard copy, the one that you have through your printer. Okay, so now you know that we use printers to convert soft copy to hard copy. So the same way you can use scanner to convert hard copy into soft copy. So the scanner is actually the input device through which you can place your document. If you have your result, maybe somebody is in another state and the person asks for that result exactly as it is. Even you can sign your signature on a paper, scan it and send to someone that you trust. Okay, so we have the scanner, we have light pen. So I want to explain this digitizer. We already know that computer is a digital electronic. That is, the digitalization of computer has to do with the numbers that the computer understands. Computer doesn't understand any other language than ones and zeros. So this digitizer is a hardware that converts analog signals to digital signal, which computer would read and understand. Okay, I have an assignment for you guys. The assignment is you give me the uses of the input devices listed here. We have about 12 input devices, examples of input devices here. So just let me know the uses, the usefulness of them. So we have here keyboard, mouse, scanner, barcode scanner, light pen, optical character reader, magnetic ink card reader, digitizer, trackball, microphone, optical mark reader, and joystick. There is one other input device that I couldn't mention here. That is digital camera. So it's still an input device. So we use it to feed image into the computer. So I was trying to explain the usefulness of digitizer. So what happens, since the computer is a digital electronic, the digitizer, in case you have an analog signal, that is, an analog signal is a signal with continuous flow of data. Like if you go to riverside, you will see how the waves of the water act. You will see how those things are continuously flowing. So the one we talk about, digital signals, are simply ones and zeros, which is what computer understands. So the digitizer is like a converter. It converts from analog signal to digital signal. So that's it for input unit. The next one is storage unit. This is a unit of computer employed to store the information and instructions to be processed. So that is to say that the storage unit can also store data, because when we talk about instruction to be processed, that has to do with data, what you feed to the computer through the input unit. So for instance, the RAM is a temporary storage. In fact, it is a storage device that stores instruction in transient. That is to say that RAM works when the computer is on. Once the computer is down, the RAM is erased. So we have examples of storage devices. Example is hard disk drive. Another one, floppy disks, tapes, compact disks, DVD, USB, flash drives. We also have memory card. I could not mention that here. We still have memory card. You can use it to store data and information. Is that okay? So, in one of our lessons, we are going to talk about the levels of storage that we have. We have different levels. We have like the bit, B-I-T. That is the lowest size of storage. After bit, we have many. We have byte, we have kilobyte, we have terabyte, megabyte, gigabyte. We even have up to yogabyte. So as we continue, we are going to talk about them, what they stand for. Okay, can we move ahead? Okay, so let's move forward. So we have the next one is arithmetic logic unit. So this is a combinational digital circuit that performs arithmetic operations on integer. Of course, when we mention integer to computer, you know that we are talking about binary, because that is the language of computer. So arithmetic, those integer, those integers, when you want to add, subtract, multiply, those things are taken care of at the arithmetic logic unit. So as we continue, you are going to see that computer does not carry out subtraction. It doesn't carry out subtraction operations. Instead, when you say subtract, the computer actually adds. So as we continue, we are going to see how computer adds. As you are telling the computer to subtract, it will add, and at the end it will still give you the same result that you had when you were subtracting in your base 10, in your decimal. So arithmetic logic unit is actually that unit where arithmetical operations are carried out, such as plus, minus, those small things like that. They are carried out at the arithmetic logic unit. So the next one is control unit, a combination of the control unit and the arithmetic logic unit. So this is how they work. We call it machine cycle. So when you give an instruction, what happens is that the instruction will go to the memory, to the main memory. Can you see here? It will go to the main memory through the input unit. So any of the input devices that you are using will send the instruction to the main memory. So just like if you want to, there are some doors now that are electronically locked. For instance, you go to some places, you have to place your eyeball on their eye scanner for the door to open. There are some places you go, you have to put your fingerprint for the door to open. Some places you have to talk. There are some cars now that you use your voice to start them. You don't use key. So there are some cars now that have voice control. So those things are basically they make use of computer. They install computer through they install a microphone there. So when you talk, the instruction will be deposited in the memory of that computer, and fetch instruction from the memory. Instruction fetch will come into play. When that happens, the instruction will be moved to the control unit. Are you following me? Then the control unit will decode that instruction into commands. You know what it means to decode something? Just like you packed something, you packed something was put inside a pack, like soap. Are you with me? When you buy soap, most of the time they come with packs, right? So by the time you unpack the soap, you have decoded it. You have explored it. You have opened it to know what it tells, what it has inside. So the control unit is the unit that will decode that instruction and convert it to commands. It is a command that computer understands. Are you following me? Because instructions may come in high level language. they may come like in form of Java. So Java is a high level language. So it is the compiler will step in and move it to low level, which is ones and zeros. So the control unit will decode it and moves it to ALU, arithmetic and logic unit, arithmetic logic unit. So let me just explain this. It's just like you want to go to a certain location, you want to go to a certain place. So what will happen is that you now tell, maybe you plot the graph, you can log on to GPAs and see where you want to get to. By the time you log on to your GPAs, the computer, maybe you give that instruction, follow this route and take me, okay, I want to go to a certain place. So the control unit will now unpack the instruction and convert it to command. Then the ALU will calculate what it will take, what it will cost to arrive there. The ALU will calculate and know the different routes that you can take to reach that place. By the time the ALU calculates that thing, the computer now, the ALU and the control unit will now see this route will demand a lower time. Are you following me? A shorter interval. Are you there? So the ALU will check and see, okay, this route now will take a shorter time. This route now will consume lesser power. This route now will consume lesser resources. Are you with me? Then they together will push the result to the main memory, and they will now, control unit and the ALU will combine, will stay together and combine and say, okay, take this route. That is how they work. That is why we say that the control unit and the ALU are the brain of the computer. Are you following me? Because everything moves from the brain. If somebody comes now, maybe and strikes you, you see that the place that the person struck you, that body portion will send signal to the brain. And instantly, the brain will send stimulus and say, okay, do this. Are you following me? Sometimes somebody wants to slap you. The eye, which is a sense organ, will sense it and send signal to the brain. Right, just instantly, the brain will tell the hand, oh yeah, lift, block the person. Are you following me? So that is the same thing that happens here. So when you give instruction through the input unit, the instruction goes to the storage. Are you with me? Then the control unit will pick that instruction and convert it to commands. Then moves those commands to the ALU. The ALU will analyze everything that will be needed to perform that command. Are you there? It will analyze every possible route, every possible ways to achieve that thing. It will analyze and execute the commands. Then the result will be stored in the memory. Are you following me? That is where your another unit that will be discussed soon will step in and pick that result and display whether on the screen or on a paper. So we are still going there. Do you have any question? So I believe you now understand how the ALU and the control unit work. How they work together. This one will not leave the other one. Two of them make up what we call central processing unit. So the next unit that we are looking at is called the output unit. The unit through which the computer interacts with the user. Output unit. So this is the unit. If you just go through the input unit and interact with the computer, I don't think the interaction will be complete. We were told that for communication to be done, there must be feedback. Is that true? So it is through the output unit that you get feedback from the computer. So I say that, or we believe that the output unit is the unit through which the computer interacts with the user. Okay, so we have examples of input or output devices. Remember, just like we had input devices that made up our input unit, we also have output devices that make up output unit. So example of the output devices that we have here speaker. So when somebody talks through the microphone, we should be able to have an echo of that person's talk through the speaker. So we have monitor. Whatever goes into the computer, exception of programs, exception of software, we should be able to see them. Are you following me? Are you with me? So the monitor displays what is being processed. It displays what has been processed. Of course, the headphone is still a speaker, a form of speaker, right? So we have plotter. We have plotter. This one works like a printer. It uses something like pin, something like what artists do. It will just be punching like that and give you an output that will be in a pictorial form. Are you with me? We have projector. Projector is also an output device. Projector. So you connect the projector to your computer. Whatever, you can duplicate the monitor of your computer to display on the projector. Are you following me? So the projector is basically to mimic what the monitor has. Its work is to duplicate it. Even though you can use projector in place of monitor, but the monitor has to be there. Are you following me? So we have projector, we have printer. We have printer. So printer is the output device through which we print, just as the name implies. Print. What you typed on through your keyboard to the computer, you can decide to print it on paper. And when such need arises, there is no other way to achieve that without the use of what? The printer. So we have other output devices. These are not the only ones.